Welcome to leveraging Sigstore capabilities in a local environment. I'm Chad Coleman. I'm a software engineer with Lockheed Martin. So within Lockheed Martin, I work on the software factory team, which drives and implements DevSecOps initiatives. Traveling today, I don't know about you, but I always forget something. So it's always an adventure when I show up. What did I forget? So this time around, I forgot my shampoo and my soap. Now, thankfully, the hotel provides that, but to me, I smell funny. So I apologize. I also forgot Red Bull, which is absolutely critical, and I'm sure they sell it somewhere around here, but I did not find it because I didn't realize it till this morning. Thankfully, we were provided a whole bunch of coffee, and I have been taking advantage of that, so thank you very much. All right, let's go over our agenda real quick. We're going to go over some background. We're going to look at the needs that we derived from that background. We'll take a look at the solution we chose to satisfy those needs, how we implemented the solution, how we utilize the solution, and where we see that solution heading to in the near future. We'll wrap it up with a very quick conclusion. Let's get into it. So on May 12th, 2021, the White House issued Executive Order 14028, improving the nation's cybersecurity. It requires government agencies to add language to their contract or to their contracts that will require suppliers to commit to and deliver auditable proof of compliance with a number of supply chain security best practices. These requirements will flow down to suppliers of suppliers, all the way down to fourth or end party relationships, including open source products and utilities. Included in these requirements are delivery of a software bill of materials for all products. An SBOM is a complete list of all components that make up a software deliverable, as well as auditable attestations that demonstrate compliance with the defined requirements for developed software, as well as attest to the integrity and provenance of third-party software, whether contracted or open source. This creates a significant challenge. How will federal contractors generate auditable proof of compliance without bogging down developers with mountains of overhead? As the federal contract language started to evolve, it became clear that we needed to establish infrastructure to support the secure supply chain requirements. Notably, we needed to implement generalized signing infrastructure for cryptographic signatures, both to establish provenance of third-party software and to generate provenance of software developed in-house. Said solution needed to be both tamper-resistant and tamper-evident, meaning difficult to corrupt, but enabling easy detection of corruption. We recognize the inherent disadvantages of user-managed keys that Hayden referenced, both in terms of sharing public keys and keeping track of keys. As I think we all know, user management of keys is often a disaster waiting to happen. Here's the rub though. We needed to have complete control of the entire signing and verification stack, including root key material, and to be able to host private deployments. And ideally, we wanted to implement this as invisible infrastructure, or as close to invisible as we can make it. Enter Sigstore. Sigstore's Recore hosts an immutable, append-only transparency log that can be used to record sign metadata, which can be queried by downstream consumers to help them make informed decisions on trust. It is tamper-resistant, and it can be audited for consistency using the Recore Monitor or Omni Witness tools. Sigstore's Fulcio is a certificate authority designed to provide short-lived signing certificates for OpenID Connect identities. Included within is a certificate transparency log, which is separate from the Recore transparency log, but similar in concept. Immutable, append-only, and cryptographically verifiable, thus enabling public auditability. Fulcio is the component that eliminates the need for users to manage keys. It accomplishes this by associating a public key with your identity and binding it to the signing certificate. Sigstore's cosign is a command line tool that is used to sign and verify artifacts. The base sign and verify commands are aimed specifically at containers and seamlessly integrate with container registries. Cosign also has sign blob and verify blob commands that can be used to sign and verify any artifact. Cosign supports keyless signing when paired with Fulcio and Recore. Of note, and as Hayden referenced, I am just scratching the surface of cosign's functionality. It can also be used to generate and verify attestations, interact with Docker files, download artifacts, and display supply chain security related artifacts for an image, SBOMs, signatures, attestations. Rekor and Fulcio can be deployed as self-hosted services, which directly addresses and satisfies our need for for private and non-public deployments. There is still a matter of establishing and managing a root of trust. If using the public good instances of Fulcio and Rekor, users need to trust the Sigstore root of trust, the Fulcio root CA certificate, and the Rekor public key, both chain up to the Sigstore tough root. As noted earlier, we needed to have complete control of the signing and verification stack, including the root key material. Anticipating this need, Sigstore implemented support for what they call Bring Your Own Tough, which enabled us to set up our own root of trust, satisfying the requirement for full control of the trust root. Note that Bring Your Own Tough is not a requirement to run private deployments of Rekor and Fulcio. It is only required if there is a desire to establish your own root of trust. For our solution, we created internal Kubernetes deployments of Rekor, Fulcio, and Tough. Deployments were rather conventional, with the majority of changes being to specify locations for internally hosted deployments that default to public good instances. We utilize many of the built-in integrations such as AWS KMS and are planning on adding more in the near future. So early on in the testing of our internal deployment of Fulcio, we discovered an issue with our planned implementation. We wanted to support linking a service account to an Oauth client, which would utilize the email identity type. However, for the sake of making adoption as easy as possible, we did not want to require a linked service account. The issue here is that using the email identity type triggers Fulcio to extract the email from the OIDC token. Thus, if a person created an Oauth client without a LinkedIn service account, no email would be extracted from the token. Our solution to this was to modify the response when this failure occurs. Instead of returning an error, we construct an email by combining the token subject with the known email domain of our Oauth client. Now note, this is a very niche use case with an even more niche solution. We also developed reusable Gitlab pipelines that simplify and streamline interactions with the ecosystem. For example, to sign an artifact, a user needs to initialize cosign to their toughroot URL, obtain an identity token from their OIDC provider, and parse that token from the query result before they can sign anything. That amounts to the pages of code you see here on the left. We pushed all of that functionality into a reusable pipeline, which the end user can include in their pipeline, eliminating several intermediate steps to sign an artifact. Now, while I'm somewhat overstating the simplicity here, the code you see on the right is what users need to add to their CI/CD pipelines to ensure the container they are building is signed. Let's talk about utilization. We're utilizing the Sigstore ecosystem to easily sign internal software, container images, packages, and other software artifacts, generating provenance to meet our new contractual requirements. Cosign easily integrates with container registries, for example, Gitlab and Harbor, enabling easy incorporation into existing processes and infrastructure. Naturally, we also use the ecosystem to validate signatures. Now, there's one more use that may be a bit unique, and it's a process that we call countersigning. One need that was identified early on was the ability to validate third-party images and packages in an offline or intranet-only environment. In order to accomplish this, we perform provenance validation on packages and false containers that are pulled through a proxy cache, then sign said packages and containers in our private Sigstore ecosystem. This enables subsequent users of said packages or containers to validate the signatures against our private deployments instead of reaching out to the internet. Aligning with the goal of invisible infrastructure, this entire process is in the background without interaction from the end user. 5-minute warning, is that what? Okay, I think I'm good. So one way that we're looking to enhance our use of Sigstore is by utilizing our stuff, the repository service for Tough. Setting up a Tough deployment requires users to design and implement an integration with their repository of choice, which can be a complex process with an inherent risk of fragile integrations. To fit our immediate needs, we created an in-house solution to handle actions such as storing and managing metadata files and automating the rotation of the keys used to sign the individual tough roles. Our stuff encapsulates this design, eliminating that work as well as the potential security and/or stability concerns that can arise from a bespoke implementation. An improperly secured solution introduces the potential of tampering, and one of the prime directives of our stuff is to mitigate this risk. We consider our in-house solution to be temporary and intend on migrating to our stuff in the very near future. Another item on our list of near future changes is to replace our OIDC identity provider with Gitlab. We currently use Oauth Manager, which requires users to set up a client, configure out how to interact with said client. We streamline this process as much as possible using Gitlab reusable pipelines, but we think we can do better with Gitlab integration. All developers in the company are already tied into Gitlab, making it a prime candidate to use as an identity provider. Another item that we're working on now is how to duplicate this local environment setup for truly isolated networks that have absolutely no internet connectivity. While much of this amounts to copy and paste work, there are several external entities that our local deployment relies on, such as AWS KMS, RDS, and S3. These are not necessarily problems that we need to solve ourselves. Rather, it's a matter of determining which solution or solutions best satisfy the unique needs of these truly and completely isolated networks. We anticipate that part of this solution will involve the use of Hopper, an open source transfer tool that bundles software and its dependencies based on an SBOM or SBOMs to simplify the process of transferring between environments. Future development may incorporate signatures and attestations and even potentially Sigstore components in an effort to support asset verification in air-gapped environments. In our quest to satisfy the contractual requirements that are flowing down as a result of Executive Order 14028, we found the Sigstore ecosystem to be effective, both from a technical and cost perspective, at providing generalized signing infrastructure. End user utilization can be greatly simplified and streamlined by employing reusable GitLab pipelines and by integrating into existing infrastructure. The ability to create local or intranet-based deployments provides a straightforward path to satisfy company privacy and security concerns, as does the ability to set up our own root of trust, ensuring full control of the entire signing and verification stack. We anticipate that replacing our in-house solution for tough repository integration with our stuff may simplify the process of setting up a root of trust, while at the same time greatly enhancing the security of the entire system. We'll be leveraging our experience with local deployment of the Sigstore ecosystem to develop substantially similar deployments in hyperlocal, truly isolated networks. And that's everything. Thank you, everyone.